Okay. One orbit around Earth, and sometimes maybe 3 orbits or more, and each orbit is 90 minutes. So the ship is probably, reusable about every 6 to 8 hours. That's why we say sort of 3 times a day for the ship. And in theory, the booster is capable of being reused every hour. So the propellant pumps are designed to fill the rocket in about half an hour. So this really is designed for rapid reusability. The orbit for orbital refilling, the payload to an orbit for orbital refilling to about 200 tons, which is going to be very important for getting to Mars. So for getting to Mars, you also need the orbital refilling. Just like you have aerial refueling, the rockets will need orbital refilling. It's actually mostly oxygen. There's 3.5 tons of oxygen for every 1 ton of fuel. So that's why it's refilling, not refueling. So it is a fluid transfer. So yeah. Play a little Barry White, Okay. So that's one of the technologies that is necessary for getting to Mars. So the ship would get to orbit with its payload, and then in orbit we'd refill the tanks, so it would have enough propellant to get to Mars. Mars is far. So now this is essentially docking in orbit, and with Dragon docking with the space station, this is a technology that that SpaceX has become quite good at. We've done, but then there was an extra half-barrel section that the team deleted, and totally accidentally it's 69 meters. It's also booster 4 and ship 20. I mean, this is a pure coincidence. Those numbers won't leave me alone. It's just, I hope it's good luck. So yeah, so propellant capacity is like around 3,400 tons. I think like I said, it'll probably it will increase over time. Probably get to 36, maybe 3,800 tons. Thrust is around 7,600 tons. That'll probably increase too over time. Just to put this into perspective, though, the Saturn V was 7.5 million pounds of thrust, and Starship is 17. So it's more than twice the thrust of a Saturn V, which was that's the largest rocket ever to get to orbit. The next booster, we actually increased the engine count to 33. We've kind of bounced around on engine count, but because I think at one point we had like 37 engines, and then we went to 29. We finally settled on 33 engines, which is about actually the most number of engines you can actually fit under that booster without like expanding the diameter. Yeah, and then this time we could get that to probably 250 tons. So that's and it's also significantly simplified. So you can see the difference between V1 and V2. The V2 is V1 looks like kind of like a Christmas tree spaghetti pile. A lot of fiddly bits, and V2 is greatly simplified while also increasing thrust at the same time. So it actually Raptor 2 costs about half as much as Raptor 1, despite having much more thrust, and I think just generally being a much easier engine to build and a more robust engine. So. So yeah, so Raptor 2 is pretty sick, and we've actually, the peak thrust that we've operated Raptor to at this point is 247 tons. And so I'm confident is where are the other two possibilities. And then because we have had a lot of launches going out of the Cape, we didn't want to disrupt the Cape activity, the operational launches, with sort of the advanced R&D of Starship. So it was important to decouple the operational launches from the R&D launches, and that's why we're at this location. And once again, I'd just like to thank Cameron County and the Brownsville South Padre and the Starship missions. Orbital flight is really just the beginning. So we're going to have a number of Starlink missions that will launch Starlink satellite version 2. But even more exciting than that is the NASA human spaceflight mission. We're incredibly honored that NASA has selected Starship to take astronauts back to the moon for the first time in half a century, which is kind of mind-blowing. So,
You're expecting to hear in a couple weeks about the possible finding of no significant impact from the FAA. Have you gotten any indications if that's going to come through, and what is your time frame for the orbital flight test? Thanks.
well, we don't have a ton of insight into where things stand with the FAA. We have gotten sort of a rough indication that there may be an approval in March, but that's all we know. That's all we know.
So, hi Elon, Marcus Harvey. Can you talk about the point-to-point capability? Is there a possibility between here and Cape Canaveral?
Oh, well, yeah, I guess technically yes. So, I mean, depending on how good things get with Starship, there are some scenarios where it might actually be the lowest cost means of transporting cargo long distances. So the interesting thing is that pitch dark in front of me.
It's fine. Hi, Elon. Michael Sheets with CNBC. You opened this presentation by addressing a little bit of the criticism that's been aimed at space travel being seen as maybe a pet project or not really valuable to folks who have problems here on Earth. I was wondering if you could get a little more into the specifics on comparing not just the U.S. government spending that's happening on space travel versus other things, but maybe in terms of SpaceX itself, how you and private investment on a dollar value compares to the taxpayer-funded projects or contracts that SpaceX has won over the years.
Well, I think objectively, the cost efficiency of SpaceX is the best in history, I think, for any rocket development. And we are talking about a rocket that's more than twice the mass and thrust of a Saturn V, and also designed to be fully reusable, which is obviously also much better from an environmental standpoint to have a fully reusable rocket, for a development cost that is, I don't know, between 5 and 10% of Saturn V. So that's pretty good. Because we need to make it work, so it's not worked yet, but it will work. Might be a few bumps along the road, but it'll work. I feel at this point, highly confident that we'll get to orbit this year. That's we're making a lot of rockets, making a lot of engines. We're close to achieving a Raptor 2 every day production rate, so sort of 7 a week, which is tough for a complex engine. And I think by the end of this year, we'll be able to produce a ship and a booster per month. So this is I don't know, at least an order of magnitude, maybe 2 orders of magnitude more efficient than.
To do a deeper environmental review of Starbase, and then one other thing, you might be able to give us an updated figure on what it costs to Starship and what it would cost to our cost a customer to buy a flight on one? Thanks.
Yeah, I mean, I am optimistic that we will get approval. Like I think objectively, I think this is not something that will be harmful to the environment. We've obviously flown the ship several times and done multiple landings and takeoffs and landings, and we've fired the engines a lot. So I think the reality is that it would not have a significant impact. Now, of course, that doesn't mean things don't get delayed from a regulatory standpoint. And we are in a litigious society, and so there's always sort of lawsuits from someone, lawsuit city. Now we do have the alternative of the Cape, and we actually applied for environmental approval for launch from the Cape a few years ago and received it. So we actually are approved from an environmental standpoint to launch from 39A. So I guess our worst case scenario is that we would, I don't know, be delayed for 6 to 8 months to build up the Cape launch tower and launch from there. From a cost standpoint, the costs will improve significantly over time. So, because it'll take us a moment to achieve full reusability and full and rapid reusability, we'll probably lose a few vehicles along the way. With Falcon 9, I think it took us 14 or 15 attempts to successfully land the first booster.
I wanted to know, when and how do you plan to test Starship refueling in space? And also, aside from NASA, Dear Moon, and Starlink, can you elaborate on the potential customer base for Starship? Thank you.
I apologize. I zoned out for a second. I was just thinking about something. Could you say that question again?
Sorry. When and
We have some mic issues.
okay. When and how do you plan to test Starship refueling in space?
Yeah.
And aside from NASA, Dear Moon, and Starlink, can you elaborate on potential customers for Starship? Thank you.
I think orbital refilling, and I want to emphasize it is refilling, not refueling, because it's 3.5 times as much oxygen than fuel. So we mostly are carrying oxygen up there. I optimistically, towards the end of next year, I think I'd be surprised if it's longer than 2 years for doing the refilling. And there are a lot of additional customers that will want to use Starship. I don't want to steal their thunder. They're going to make their announcements, and but I think this will get a lot of use, a lot of attention. It's like I said, once we make this work, it's an utterly profound breakthrough in access to orbit. And when you have an utterly profound breakthrough, the use cases will be hard to imagine. I mean, when aircraft first came along, aircraft were viewed as toys, like they were like a novelty, not a means of transport. They were like, oh look, we can fly like a bird briefly and dangerously for a few minutes.
So you've talked a lot about how Raptor 2 is crucially important for Starship development and for the future of Starship. So I'm curious, what general improvements have you made with Raptor 2 to ensure it's not only more efficient and more powerful, but also much easier to produce and less expensive as well and faster? And how do you plan to continue to iterate further on the design in the future?
So, Raptor 2 is an almost complete redesign relative to Raptor 1. So basically everything from the turbomachinery to the chamber nozzle, the electronics, basically everything's been redesigned. You can see the difference over there, the Raptor 1 versus Raptor 2. A lot of the changes were deleting things. We deleted a lot, consolidated a lot. The rotating machinery, especially the inducers of the turbo pumps, are a lot more robust. We converted a bunch of flanges to welds, and we're actually over time will convert even more flanges to welds. I hate flanges, especially if you've got high pressure and a cryogenic fluid or super hot gas. Flanges and seals are a nightmare, and so we've got parts of that engine that are sort of 700-800 bar, sort of 11,000-12,000 psi, which is nutty, and so just going to welded joints instead of flanges was pretty helpful. The pre-burner controllers have been consolidated into a sort of a unified box as opposed to being kind of like all over the engine. And we're getting close to the point where I think Raptor will not need shrouds. So shrouds are a huge pain in the ass, like basically putting a whole shield around the engine, especially.
Sorry, yeah, Chris Gephardt with NASA Spaceflight. Can you talk a little bit about the abort modes that are available for ship if there were ever to be a problem during the climb to orbit? What would be available to the crew in that regard? And also on that same level, the life support systems for ship. Where do those stand, and what are the challenges that you're finding with just the sheer volume in Starship for that? Thank you.
So Starship will not have an independent abort system, but I think something that would make sense is to have the thruster weight of the ship be enough that it could do it could take off from the booster even if the booster has a failure at the pad level. So if you can get the thruster weight of the ship at sea level above 1, then even if there is something goes wrong with the booster, the ship can essentially fly away from the booster. And so that's something that I think would be important for carrying people and also for high-value cargo to have the ship have thruster weight greater than 1 even at sea level. And then there's like I said, that would be like the 9-engine version. And then even if you lost 1 engine, I think you should still be able to do an abort. So I think for crewed missions, we would essentially maybe detank the ship to some degree so that you'd have kind of a launch abort capability with the ship, even if you lost an engine. That'd be my recommendation. From a life support standpoint, we would have a sort of a renewable, like for long, we could scale up the life support system in Dragon. That would certainly be an option, and that would work for missions that are, say, a week or 2 weeks. That would be fine. For missions to Mars, you'd want a life support system that is renewable. Or it's essentially recycling.
I'm wondering if you do get that approval from the FAA in March. I know that there's really no way of knowing, but could you talk a little bit about the hardware readiness, sort of where you are technically? The launch tower is pretty incredible, but sort of the rocket, the ground system, software. Like if you were to get some kind of approval from the FAA in March, would you be looking at, how quickly could the hardware be ready to go?
Yeah, I mean, I think we're close to having the hardware ready to go. So right now, I think we're tracking to have the regulatory approval and hardware readiness around the same time. Yeah, so yeah, around the same. Hopefully, basically a couple months for both. Yeah.
Where are you at as far as production? How many do you have? Are they how are they handling testing? Are they more cantankerous, less cantankerous? Just give us a little more rundown, like on where you're actually at. Is that a bottleneck for the next booster as well? We assume the next booster is going to require, Raptor 2. So, kind of where are you at with the production and the testing so far?
Well, I mean, right now, of any technical problem, I'm spending the most time personally on Raptor 2. Like really, they're like the two things that occupy the most number of mental cycles are Raptor 2 and Tesla Full Self-Driving. The only remaining issue that we're aware of is melting the chamber. So that thing really wants to melt, It's got like on the order of a gigawatt of heat, so it's pretty hot. Like a gigawatt's like what a nuclear power plant produces, so it really is desperately trying to melt at any point in time. We've got, we're flowing an immense amount of cryogenic fuel to cool the chamber in the channels. We have head-end film cooling, we've got throat film cooling, and we're just trying to get the exact sort of balance between head-end film cooling and throat film cooling to not melt the chamber. I think we're pretty close. Like we have a couple engines in the stand that have I think 700 or 800 seconds of operation and several start cycles. So it's looking positive, but that's the remaining issue is melting the chamber. It is, by the way. Yeah.
Hi, Elon. Robert Perlman with Space.com and Collect Space. You mentioned the NASA contract for the human landing system. At one point, do you envision splintering off development of Starship for HLS, or how are you going to balance the timelines of rapid reusability versus NASA's own schedule of when they're ready to go to the moon?
I don't think there's really a conflict there. We're going to be making a lot of ships, a lot of boosters, obviously a lot of engines. Yeah, it's kind of interesting. Like with the booster with 33 engines and the ship with 9 engines is 42. There we go again. And that also total coincidence. Adding legs to land on the moon, we do not think is like that can be done pretty quickly. I don't really see any conflict between achieving rapid reusability and getting to the moon. A high production rate solves many ills. So we're aiming for a high production rate.
Hi, Lauren Grush. The number of launches that you plan to conduct in order to do these refillings. I know a lot of numbers have been thrown around, so I'm wondering if you have landed on a final number. And how quickly do you plan to launch those missions back to back to refuel the vehicle to get to the moon? Thanks.
Yeah, so the missions would happen pretty fast for refilling the vehicles to minimize boil off of the cryogenic propellants. Now for the vehicle going to the moon, we have some installation to minimize boil off. But we'd probably be launching, I don't know, probably every few hours. Aspirationally. So, yeah.
Hi, Elon. Kevin Haymeyer from Space Eccentric on YouTube and Rumble.
Bob Duncan. I'm a local resident. Are we cutting out? Is that better? Hi, evening. My name is Bob Duncan. I'm a local resident here in the area. And first off, thank you for a very cool evening. So this has been a lot of fun for us. As a local resident, it's been exciting to watch the amazing progress that SpaceX has made here in Boca Chica. And I was just curious, we're standing on the southern tip of the state of Texas. We're a few hundred yards from your residence. Could you just speak to what, if anything, has been appealing or advantageous about operating in the state of Texas versus other parts of the country? Thank you.
Well, I think we've, you know, the well, I mean, we've had a lot of support from the community, and something that just happens over time with societies is that kind of rules and regulations build up, and they build up, you know, more in some places than others, and they didn't, I think Texas has the right amount of rules and regulations. Yeah. So, thank you all for coming. I hope you've enjoyed the evening, and I think we might be able to get you closer to the rocket if you'd like. So we'll get you as close as possible while still being safe. Yeah, feel free to take pictures, have a good time, and let's go like hell to have an exciting future. Thank you. Let's make this real. Yeah. Cool.